Welcome back. In this presentation, I will be discussing about the partnership status table, also called as PST. PST is a physically addressed metadata. In our previous videos, we discussed about disk header, which was also a physically addressed metadata. Now in this video, let's know about the partnership status table. As we already know that every disk is formatted into allocation units, and the very first allocation unit of every disk, that is allocation unit 0, is reserved for storing the disk header information. Similarly, AU1 is reserved for storing the partnership status table, which is called as PST. As the disk header stores information relevant to that disk, whereas the PST contains information about all disks in a disk group. It contains information like the disk number, its partner disk, and the failure group, and finally the heartbeat information. As I said that the allocation unit 1 on every disk is reserved for storing the PST. Not all the disks in a disk group will have this PST information. Now let's clarify this point. Let's take we have a disk group of external redundancy. On external redundancy, we only have one copy of the PST. Now let's go for the normal redundancy disk group. In a normal redundancy disk group with two failure groups, two copies of the PST are maintained in allocation unit 1. Let's say if we have 3 or more than that failure groups in a normal redundancy disk group, then we'll be having 3 copies of the PST maintained. In this slide, we can see that we have 4 failure groups that are part of the disk group 1, but we have only 3 copies of the PST maintained in the first 3 disks. If you are looking in the slide, the last disk, the AU1 is reserved for storing the PST, but it doesn't have this PST information. Similarly, if we are going for high redundancy disk group with 3 failure groups, then we have 3 copies of the PST maintained. And if we have 4 failure groups in a high redundancy disk group, then we will be having 4 copies of the PST. But if we have more than that, if we have 5 or more than 5 failure groups, then only 5 copies of the PST are maintained. In a high redundancy disk group, in the slide we have a 6 failure group, but we have 5 copies of the PST maintained in the first 5 disks, whereas in the last disk, AU1 is reserved for PST, but it currently does not hold the PST information in that. Now let's see the PST relocation. Let's say if a disk which has the PST information is not available at the instance startup, then the GMON process will relocate the PST information from the other disk to the disk which was not having this information before. Now in this case, the first disk was not available at the time of instance startup, and the PST information that is there in the disk will also not available. So in that case, GMON copies this PST information from the other disk into the disk which was not having this information before. And the second case is that if due to some IO error, if you are not able to read or write to this PST information on a disk, then the GMON process will copy or relocate this PST information to the other disk which was not having this information before. And the third case, if a disk goes offline and the disk was already having this PST information, then in that case, the GMON process comes into the picture and it copies the PST information from the available disk to the disk which was not having this information before. And in the other case, if you are dropping a disk from the disk group gracefully, then the PST information from that disk or from any other available disk is copied to the disk where this information was not existing before. This is about PST and PST relocation. In our next video, let's see these things practically. Thank you.